Our next presenter is Julian Gray, the Chief Executive Officer of Smart WaterMark. Julian has an educational background in international communications and environmental science and 25 years experience in a great number of sectors in a number of countries. He is an active member of the International Water Association's Public Communication Network and is co-author of the Australian Water Association's position paper on water efficiency. Julian, thank you.
Thank you, Jamie, and thanks again also to AWA for organising this forum. In this second session and the last session of the morning, we're going to be continuing in the collaborative policy and practice area, and I'm going to be talking about implementing a programme to identify and promote the synergies in the water, energy, food network. And I'm going to talk in three sections. The first section is going to be a brief overview, looking at the water, energy, food nexus, building on several of this morning's presentations. Then I'm going to look very much through the lens of the water, food, energy nexus, through the case of water efficiency and how that fits in within that nexus. And then thirdly, I'm going to look specifically at efficiency certification to promote new technologies and best practice to get the best value from water. And I'm sure that'll be a discussion we'll have later about what is the best value of water. Now, I thought I'd give you a quote from the Secretary General from the UN, which has resonance with today's forum. And in his address on World Water Day, he said that the many strong links between water and energy demand coherent, integrated policies and innovative strategies. And we've heard about several of those today, and I'm sure we'll hear some more later. But I thought that would give a nice big picture. As Jamie noted earlier, this is a global issue, and Australia is a testing ground. Australia is the driest inhabited continent on the planet, and there are issues of severe water scarcity across Australia. Now, in terms of how we use our water, Australia has quite a high water usage in terms of agricultural sector, higher than China and significantly higher than the US and the UK. It's also got a reasonably proportionally high municipal water use as well. I wanted to raise the issue of water footprints while we're talking about the big picture. I presume we're all aware of carbon footprinting. Water footprinting is taking similar kind of processes. It's allowing us to gain a better understanding of embedded water in produce, and it's helping us to inform decisions potentially about what we grow and where we might grow it. And I think it's an issue which we need to draw into the whole water, food, energy nexus. As we're seeing changing demographics and changing diets to a much more Western-based diets in many developing countries, we're seeing the water and energy input into those foodstuffs rising. Looking now more specifically at the case for water efficiency, a point that's come out a couple of times in the forum over in Melbourne and up in Brisbane was the history of water efficiency measures and water efficiency programs really stems quite strongly from the 1970s in the US, from the energy sector. In the US, the energy sector had a major crisis and wanted to try and work out ways of reducing energy use as quickly as possible, and they found reducing water use was a very quick way of doing that, and it started developing water conservation programs. Over in Australia, it's almost been the flip side. Water has been the issue, and the energy sector has been coming to it at a later stage. Now, the Australian Water Association has a water efficiency network, and they have developed a case for water efficiency, trying to really identify why we need to have water efficiency outside of drought. The paper was published in October 2012, and was subsequently, a similar kind of paper was produced by the Water Services Association of Australia in 2013. And both of them really are setting out the position of why we need to be efficient in our water use. And it's not just about crisis management during drought, it's about wider water security, it's about resilience, especially in light of climate change, and I'll come to that a bit more in the future. It's about resilience in terms of population growth and the numbers that are predicted for population growth across Australia, and also the demographic change the change in the demographic profile, and therefore in how we use water in Australia is also quite interesting. And obviously the water energy nexus kind of fits in with all of that. This graph here shows Bureau of Meteorology data from 1910 through to 2010, showing the increasing temperature anomalies for Australia, showing we are getting increasing temperatures, and we're seeing that as temperatures increase, we're getting higher embedded energy costs into water, but also higher embedded water costs in energy. So there's a double whammy there, and it's something we need to address. And just yesterday, the New South Wales State Infrastructure Plan was announced and published, and in there it was put forward that climate variability will mean worsening water security, and it's been identified that we've got an increase in extreme weather events which will impact on more severe droughts, but also more severe floods. And both of those have a significant impact in terms of our supply of both water and energy. Climate variability is another big issue. With increasing variability, as I mentioned, we get the whole flood-drought cycle becomes more unstable. We get larger floods and larger droughts. But also, if we're planning food production, obviously more variability impacts on how well we can plan for irrigation or not to irrigate. And we need to ask the question of how do we improve our resilience against this increasing variability. Now, we can do it through improving technologies, better management practices, but also I think there is a national discussion to be had on how and where we grow our food, and also what that food might be in the future. I'm not providing answers, I'm providing questions at this stage. Now, you saw another version of this graph presented by Marguerite earlier. This is the inflows of water to the dams in Perth, and the data here goes through even more recently, and we can see that the figures are going down even more. And Perth really is the canary in the coal mine. The Water Authority and the government there are now not talking about being in drought, but they're saying that they have now changed their climate. They now just are a dry climate. So the response to that has been to look at what we can do in terms of climate-independent water sources. Now, desalination has been a big investment in WA, and Perth has now got 2 desalination plants, and in fact the first plant has also doubled in its output as well. And also Perth has now got a really exciting project looking at groundwater recharge from non-potable reuse. But with all of these new water sources, we see that there is an energy impact. And this is a graph from some research undertaken by the Water Services Association and CSIRO, and it looks at the embedded energy in different water sources. And I don't know if the people at the back can see, but if the cyan, kind of the larger kind of area there, is desalination, which is 5.1 kilowatt hours per kilolitre, whereas just to the left of that, the even lighter blue, is traditional water sources, and that's 0.51. So we're seeing a tenfold increase in energy input into water source, which is obviously significant. But we also see that embedded energy in water also has a geographic spread as well. So over in Perth, which is the fourth column there, you can see that's quite high. In fact, this graph was produced in 2009-10. Since then, with the second desal plant, or the first desal plant having doubled its output, those water supply treatment costs will have gone even higher. So we can see that the impact of new technologies is impacting in different parts of Australia in different ways, and quite often it's in the more water-stressed areas that we're seeing the higher energy input needed. Also, in terms of water supply options, a couple of points here. Water efficiency, which is this chap here, is a very good way and a very cheap way of deferring water supply. Just as also as an aside to Jamie's point about rainwater tanks, you can see there the cost of rainwater tanks go between $1.41 per kilolitre up to $12.30, depending on the how well it is designed, how well it's implemented, and also where it is, because obviously depending on the climate depends on how well a rain tank works. It's a bit like a dam. Put it in an area with no rain, it's not going to actually collect any water. It's like giving a poor man a wallet. Okay, so we need to think about, with new technologies and water supply options, we need to make sure that we're using the appropriate technologies, and we need to avoid those perverse impacts that have been already mentioned. As an aside to Marguerite's point on residential water use, another interesting issue there in terms of where the water energy nexus is met is where it's actually being used around the home and around businesses. If you could reduce residential hot water use by 15%, that would totally negate, or would be exactly the same amount of energy that we use, the total embedded energy from all the urban water utilities collecting, treating and distributing that water. So it shows you where maybe we need to look at, if we're going to be efficient, we need to be efficient where the water is actually being used rather than where we're collecting the source. Now this graph here shows you how water efficiency can offset the need for capital investment in new sources. This is a graph of Melbourne's water storage from 2002 to 2011. The bottom line is what the storage would have been if no efficiency measures had been put in, and you can see there two drops in July 2009 and July 2010 when Melbourne would have run out of water because of the efficiency measures put in, such as restrictions and hardwiring new technologies into homes. Then we've managed to avert that crisis. Looking more at a local figure example here, just to see the reduction in per capita water use across Sydney. And here we have, back in 1999, at the top left-hand corner, 420 litres per person per day used. That's dropped down to about 300 by 2011. And it's a combination of new technologies, voluntary restrictions, mandatory restrictions, and rebates, getting people to hardwire new technologies into the home. Looking specifically at efficiency certification now, this final section of the presentation, I want to kind of focus on three kind of areas. First of all, using certification to drive market transformation. Secondly, to raise awareness of the water energy food nexus. And thirdly, to promote the best value use of water. So in terms of this, I'm going to just give a quick overview of Smart WaterMark. We're Australia's water conservation label. We identify and certify water efficient technologies and practices. We raise awareness of water conservation issues, and we promote innovation in new technologies. And we're the sister scheme to the WELS rating label that you might have seen on your toilets and tapware and dishwashers. Our certification is used by government and utilities in their demand management programs and in their rebates. And we very much, as you see on the slide here, we very much work in practice. So in terms of collaborative policy and practice, we see ourselves as one part of a much wider demand management jigsaw. We're a not-for-profit organisation and a public-private partnership, and are written into the National Water Initiative. And we're also supported by government and industry. In terms of the certification process, I won't go into too much detail. All the information about how we do the certification is published on our stakeholder website, which is smartwatermark.info. But I'll just pick out on a couple of points. We use an independent technical expert panel as the certification process. So they look at all applications to Smart Watermark. They make sure they meet all standards and regulations and things are fit for purpose. But it adds an extra level of governance over stopping those perverse outcomes. And one of the criteria that the expert panel look at is the sustainability of the water savings made. So that could be in terms of energy input, chemical input, and also the impacts of those water efficiencies downstream. And so we're really trying to identify those technologies which give the co-benefit of both water savings and energy savings. And we have knocked back a number of technologies which might make great water savings, but you do it at a very high energy cost. In terms of technologies that we've assessed and we've certified across a range of areas, but quite a lot in the irrigation and the gardening kind of sector, which is where the program really started, but now more in the commercial and the cleaning, in things like rainwater harvesting, grey water systems, hot water recirculation systems, and also in the service sector as well. In terms of what are we doing in the water energy food network space, as I said, the first area was about raising awareness. So alongside the certification process, we run a number of communication campaigns with water utilities and with governments, and we linked our water saving calculators with government campaigns on how to save energy and showed people how much, when they were saving water, what the embedded energy savings were out of that water savings. So that was back in 2008. We also wanted to look at market transformation, and here's a case study of glass washers. We were working with Sydney Water and the hospitality industry, and they were looking at what technologies or what things could be done in the hospitality industry to reduce water and energy use. And the low-hanging fruit was seen as the glass washers, which there was an old technology which is wash and dump machines, and then there were new recycling machines. So what we did was we sat down and developed guidelines and benchmarks with industry. And that was quite interesting. That stakeholder engagement was really important. It's picking up a point that Michael was talking about earlier in terms of governance. And there, the industry set the benchmark with us, and ironically, none of the machines that the industry actually were developing at that time could meet that new efficiency benchmark. But within 6 months, they'd all improved their technologies to be able to meet that. What we would then do is we certified all the machines meeting the new benchmarks. Government then used that certification in a retrofit program. But at the end of the retrofit program testing period, there was an independent assessment of the savings, and we had over $1,100 savings per machine per annum. And so government said, well, we actually don't need to pay for a retrofit program here because the market will do the job itself. And so we got market transformation because it was basically a no-brainer. If someone bought 2 machines of similar kind of price, they knew that they'd be saving $1,000 running costs from buying the more efficient certified machine. So it's great to see that market transformation happen very rapidly. Finally, just wanted to talk about water efficiency certification, both in the international space but also in terms of the food side of things. In terms of, we were funded by Horticulture Australia to do some research into international certification and environmental labelling. From that, we discovered that there were very few other environmental labels in the water space. There's quite a few which are involved in sustainable farming and produce and embedded water efficiency into those wider schemes. But there was only 2 or 3 internationally which were actually doing the same kind of work as what was happening in Australia. And Australia was seen as very much leading the field in that space. So what we decided to do was to sit down and try and see if we could work a bit more in that space in terms of identifying, rather than just technologies or practices, but actually look across the whole supply chain, and could we identify the best practice and in terms of management practices and the best technologies and the best designs, so you could actually look at the development of the growing of some produce, and look at the end product on the shelf of the supermarket and certify that process in terms of efficiency. Looking at the best technologies, best designs, best processing, and the best management processes. So we've got we're developing a pilot project at this stage to look at this. We've got a proof of concept, and really the whole point would be to try and get market advantage for best practice in those areas. And it'll be very interesting to see how well that works. Looking at the timing now, I think I will move us on to questions. Thank you.